Hello, everyone, and welcome to today's live webinar on real-time design feedback with Creo Simulation Live, allowing you to bring better products to market faster with real-time design feedback. My name is Alex Janicki. I'm Director of Marketing here at TriStar, and I'm very pleased to introduce our presenter, Zach Carson. He's a virtual technical pre-sales specialist at PTC. Before we get started, I just wanted to do some quick bookkeeping and mention that a complimentary recording of this webinar will be sent to everyone who registered automatically, as well as available on our website and YouTube channel shortly after the presentation. You may also notice on the little toolbar there that there's a data sheet on Creo Simulation Live that kind of highlights some of the features we will be highlighting today that you can take away after the presentation. If you have any questions during the presentation, please feel free to leave them in the chat and we'll hold a brief Q&A at the end of the presentation, or I'll just pause and we can kind of go over it during the presentation. But before I pass it over, I did want to briefly go over TriStar for any of you not familiar with us. So at TriStar, we're a company that specializes in helping manufacturing companies adopt systems and processes to enable better and more efficient product development. We achieve this by being the largest value-added reseller for PTC products and services worldwide, with headquarters in Phoenix, Arizona, and representatives and engineers throughout North America, Canada, and Mexico. We've been in business for well over 25 years, and we're experts in CAD, data management, PLM, and product development. We also have a large assortment of custom solutions, services, and support packages tailored to specific requirements and needs. And while Creo Simulation Live, it is a standalone package, I did want to mention a final note before I pass the reins over to Zach. We do have a time-limited offer, which includes 35% off all Creo extensions running until the end of the quarter. So it's a good time to kind of think about, the advanced simulation or simulate if you're looking to upgrade. And I'll go ahead and pass the reins over to Zach, and he can get started. And just give him a moment to get a screen up here.
Okay, can you see my screen?
Yes, sir.
It's just the PowerPoint says Creo Simulation Live, right?
Correct, yep.
Okay, awesome. Yeah, we'll go ahead and get started then. Okay, so thanks for coming, everybody. Today we're going to be talking about Creo Simulation Live. It's an extension of Creo Parametric. Now, Creo Simulation Live provides you with immediate insight into how your designs and your design decisions impact the quality of your model. Now, before we jump in, I just want to clarify a common misconception about CSL. CSL is a design tool. I know its simulation is in the name. It's not necessarily, though, an analysis tool. What it does is it uses simulation capabilities to guide you in the right direction during your design process, but it should not be used as a final analysis to validate your designs. It's not meant to replace validation tools. That's why we have Creo Simulate, Creo Simulate Advanced, Creo ANSYS Simulation, those sorts of things. This is used in tandem so that by the time you get to that validation, it's going to pass with flying colors. Now, here's an agenda for today. First, we're going to talk about challenges we commonly see in the industry. Then we'll go into our solutions to those challenges, which is CSL. After that, we'll discuss some capabilities and then jump into a demonstration in Creo Parametric and finish off discussing the value it brings to different companies. From speaking to so many companies in the industry, we have found that most of them face very similar challenges. So first of all, analysis is just generally too time-consuming to utilize in the early stages of design. That's because the models are constantly changing, and designers and engineers simply don't have the time to always be updating and rerunning analyses. As a result, engineers are forced to rely on experience when making critical design decisions. And that means the design decisions aren't necessarily backed by analysis or by data, which makes them more susceptible to problems down the line. Any analysis that does take place is typically done further down the line, at which point it's not really impacting the initial design decisions. Again, it goes back to most of the design decisions are just made off of prior experience and knowledge, and that is fine a lot of the time, but sometimes it can get you into trouble, and that's costing even more money if problems do come up deep in the design process. Together, these all lead to a reliance on physical prototypes for each of the different phases of the design process, and then testing to validate the function and the performance of your designs, which is very expensive to create and execute. PTC's solution to these challenges is Creo Simulation Live, or CSL for short. This provides you with one unified modeling and analysis environment. What we've done to achieve this is partner with ANSYS. They've been a leader for years in engineering simulation, and we've embedded their Discovery Live engine directly into Creo Parametric. Now, this Discovery Live engine provides us with lots of different capabilities. First off, it gives us the ability to perform static analysis on both the part and assembly. Okay, so with this, I skipped a slide. There we go. We're able to rapidly define and perform structural, thermal, modal, and fluid types of analyses. And all this is done in a completely meshless environment. So because of the way the engine is built out, we're removing the need to manually create a mesh or manually go in and defeature the model and remove rounds, holes, interferences, things like that, things that are time consuming. With this tool, you're not going to have to worry about doing any of that. The results we get with this are instantaneous. So that includes when we make changes to the part, changes to the material, for example, or even changes to the analyses. It's able to go in, recognize those changes, and run an analysis and give us results that are instantaneous and interactive in the form of charts, graphs, and animations. And you'll get to see this in the demonstration today. In terms of the capabilities of CSL, the solver runs continuously in the background and entirely off of your graphics card. So that means your more CPU intensive tasks like creating sketches and features are essentially unaffected by what CSL is doing. Everything that we do is taking place in Creo Parametric in one unified environment. There's not different software, there's not even different windows that you have to open to use CSL. And it's all embedded within Creo, and it works great with many of the other Creo extensions and capabilities that you have in Creo, things like the design exploration extension or behavioral modeling, for example. Those are two that I see commonly used. Once your design is close to being finished, we're then able to leverage the analyses into the more traditional analysis tools that, like I mentioned before, Creo Simulate, ANSYS Simulation. Because remember, just going to keep reiterating this, this is not an analysis tool. It's a design tool that gives immediate insight if we're headed in the right direction. So using this in conjunction with those other tools enables us to integrate analysis into every step of the design process. With the release of Creo 7, we've introduced an optional feature set called Creo Simulation Live Plus. Now, what we can do with this is we can do flow analysis in the same way that we do structural, thermal, and modal analysis. And the setup is very straightforward. You just create fluid domains where you decide which areas to include or exclude, define the inlets and outlets, the materials you want to work with, and then from there, visualize it right on top of the model that you're working on. And as you run these simulations, again, just like the standard CSL that we're used to doing, when you go to do flow analysis, the results are also very interactive there as well. So you can visualize streamlines, you can take section views, look at direction fields, the list goes on, and they're all easy to use, and it's all doable right within Creo Parametric. So now I'd like to take us through a demonstration of Creo Simulation Live. Did any questions come in so far at this point?
No
Don't
questions so
see any.
far, so go
Yeah.
ahead.
All right. All right. Can you see Creo Parametric now?
Yes, sir.
Thank you. Okay, today we're going to be working with this Royal Enfield motorcycle design that we have. Specifically, we'll be focusing on this rear arm subassembly. Now, this is a part that's currently in development, so it's a great time to use CSL and run these simulations and look for potential problems areas in our design. This could also be a part that's already complete, and we're just looking to make some improvements to it. To get started, we'll go up to the top here to our toolbar and select on the Live Simulation tab. And on the left side of the screen, we have the studies that are currently out against this part. In this case, we're looking primarily at the structural constraints and loads of this part. And there's lots of options we have to examine for each of these. We have certain displacements that are predefined in the model. Of course, you can add more, remove some. We can have we also have certain constraint types like ball, cylindrical, planar. There's lots of options there depending on the use case. And then we have some different loads set up on this as well. These loads can be a variety of forces, of moments, pressures, and so on. And setting these up is really easy. You just enter the references, select the distribution of forces, and then specify the direction that you want those forces to be applied. Once you have all of that laid out, we're ready to simulate. Now, in traditional systems, if we wanted to analyze this assembly, we'd have to probably defeature the model. You'd have to get rid of the small holes, rounds, interferences, and so on. But with CSL, you don't have to do any of that. So we'll go ahead and select Simulate at the top, and you can see here how fast this applies to the model. In this case, we're going to start by looking at the von Mises stress. It has the minimums and maximums here identified for us as well. I think my screen is frozen. Is that better?
Might be frozen, but just give it a minute. There we go.
Okay, good. Yeah, so we have the minimums and maximums identified for us on the model, and that way we know the potential problem areas in our design. Here, we have the most stress where this one bracket is connecting back to the main body. So that's definitely an area that we're going to have to monitor as we go forward and as we make changes to this thing. We're going to have to see how those changes affect our value here for stress. Okay, we can also take a look at deformation. Right, so same with the von Mises stress, same with the deformation. Instantaneous results, they're interactive. We can even animate this thing and make sure that the model is responding the way that we intended it to. Is it bending and flexing as we expected? In this case, it is, and it's in the area that we expected it to be. Now, since we're in the early stages of development on this part, doing analysis-driven design like this is hugely beneficial for us to prevent future problems and get to an optimal design much faster. So based on the results that we got back from this analysis, the biggest concern at this point is with the von Mises stress on that bracket. To get a better understanding of that stress, we're going to set up what we call a simulation probe. And this allows us to monitor certain values that we're interested in and then see how those values update and change as we make changes to our model. See if whenever we make a change, if that value is decreasing, if it's, let's say, above our threshold. In this case, it is. So right now, we're sitting at about 165 megapascals of stress. Let's see if we can make some changes and bring that value down a little bit. Now, the first thing that we're going to do is update the profile of our sweep over here. It's one of the main body parts to this assembly. Instead of having the squared bottom and the rounded top, we'll just square off the whole thing. It's just a basic change, but we're going to see how this affects that value. That looks pretty good. And now we'll just need to update where that connects to the crossbar in the front as well. And that looks pretty good too. Okay, now, one of the biggest benefits we have in working with CSL is we're making these changes and then we're updating this simulation or this analysis all right within Creo. We don't have to jump to different tools. We don't even have to jump to different windows. We're just continuing to go through, make our normal changes in the standard Creo environment, but we're getting all of the benefits of these other tools that gives us live feedback as we're making these modifications that tells us whether or not we're actually moving in the right direction. Now, as soon as I updated that, you can see this value on the plot on the right-hand side, but also on that simulation probe we set up, it has changed dramatically. So from the change we made, we dropped all the way down from 165 megapascals down to about 129. So we're definitely on the right track. And we know that immediately using CSL. But let's keep going and see if we can get this value down even more. And I want to emphasize, we're looking at the value, but we're not really focusing specifically on what that value is too much. I'm looking at it to get a better understanding if the changes that we're making are leading us in the right direction. Now, obviously, that stress level came down so much that we know that we're heading in the right direction here. If it was a very small change, that's not really all that important to me because we're going to do the validation analysis in the end regardless, and that's going to give us the specific value. We're using this to tell us, are we getting closer to that finished product so that by the time we do the validation, it's, if not done, it's extremely close to being done. Next, we're going to make a little bit more of a drastic change here, and we're going to take the whole assembly and make it a little bit wider and see what that does. Again, same as before, as soon as we make the change, go ahead and update it. And that helps us decide what changes to make to improve the model even more. So we're not just making a change and hoping we're moving in the right direction. We're taking this feedback and we're using it as a guide to make the decisions and then know the impact of those decisions immediately. Once again, just like the first change, the change that we just made here dropped that stress level down even more. We're all the way down to about 90 megapascals. And if you click on that, you can see the history of those changes you've made and how they've impacted that stress level. Now, CSL enables us to keep making these changes, to keep exploring design options. Since we know the impact of those options immediately, we're going to go ahead and make another change here. Let's say that we got really good results from the straight edge profile on top and making this a little bit wider. But let's say we really liked how the rounded sweep looked. So let's try to go back to that initial profile, and instead of just having the squared bottom and the rounded top, let's round the whole thing and see how that affects our model. Does our quality go down the tube, or does our value for stress, which is pretty much the main concern here today, does that stay relatively the same?
And while you're showing this off, Zach, we did get a question. Can you set up a design of experiments to look into the effect of dimensional variation?
I don't completely understand that. Is it asking basically, can you look at just how different values would affect the quality, I guess, at once, instead of putting in a specific value or making a change, just almost conduct a study?
Yes, I believe so.
You can. And we'll actually do that here in a minute. We're going to set up a sensitivity study, which, if that's what the question is going to do exactly that.
Perfect. Basically like a sweep of values for a dimension.
Right. Yep, that's exactly what we're going to do.
Awesome.
All right, so the change was made. We'll go ahead and update this thing. Oh boy. Yeah, so that change right there is absolutely in the wrong direction. So that's fine though. That's really the point of using CSL, right? We make a change, and that might be a profile, that rounded profile. It's something that we really like. the designers really like, it looks good. That's a huge piece of the puzzle. And we might want to stick with that. So now we can take this, and obviously it bumped that stress level way up again, back to even above where we initially started. But now we can do things to try and improve on that. And that's really where that sensitivity study comes in that I had just mentioned. Okay, so at this point, we're back up above that initial value. All hope's not lost just yet. So instead of going through manually and trying out lots of different values for that profile that we want with the rounded edges, we'll just let Creo do the work for us. That's where the sensitivity study comes in, and that's part of our behavior modeling extension. It lets us set a range of possible values for that round body parameter that Creo, using Creo Simulation Live, will iterate different design options for within a range that we set, right? So here, we're just selecting the different values. Once we select the different variables, then we can set our range. In this case, I'm fine with anything between 12.5 and 17.5. And then we'll just tell it how many steps we want. 5 is easy, so that we can just go up by 1 every time between 12.5 and 17.5. So we'll leave it at that. And then we compute. And once we compute, for each value that we're testing in our profile sketch, our sensitivity study goes through and changes the dimension and then graphs out, in this case, the von Mises stress that we see in the plot. And now we can take a look at those results. So looking at this graph, one iteration of this had that von Mises stress down under 100 megapascals. So it literally cut the stress value in half from the value that we just had once we went with that rounded profile. If we just hover over that point, then you can see exactly what that value is. So von Mises stress is about 98.5 megapascals, way better than where we're at now. And for that, or to get that value, that dimension has to be 13.75. So now we have that specific value. We can just go ahead, go back to Creo. Remember, it's all done in the same environment, so you don't have to go back to, say, if you were using separate tools, go back to the design tool, update the value, send it back to be analyzed, and go back and forth and spend a lot of time and get more than one person involved, which obviously gets expensive. We can do that all in Creo Parametric. So we're going to go back. We had Creo give us the optimal dimension or the optimal value for that dimension, and now we just make a simple change. Right now it's 15. We'll go 13.75, and then we can rerun the analysis and see how it actually affects the model. Is it affecting it in the way that it told us it was going to? So this got us to that optimal value much, much faster than going in and changing the design X number of times for each value we want to test in order to find that optimal design. And honestly, if you're not looking in the right range, you might never find that value to begin with. Right? So you can see here that von Mises stress did cut in half exactly like it said it was going to. And really, the moral of the story here is you don't need to just go off gut feel or intuition or experience when making these changes. Of course, experience is going to help. So maybe instead of going through this 5 times, you have to go through it 3 times. But let's just let Creo Simulation Live give us real-time live feedback on these modifications to help us determine if we're looking at the right things. It takes all of the guesswork out of this. And as you've seen today, we're able to do this in an interface that's very straightforward. It's one that your designers and your engineers will have no problem picking up and using very quickly. Now, looking at those final results, we looked at the von Mises stress. We saw the history of those values as we've ran this analysis. And now here, same thing goes for deformation. It's moving and bending and flexing in the same area that we saw initially. The value's right around the same thing. That's a good thing. And now at this point, the design is probably a lot closer to the finish line. So then we have the option to switch over to our more traditional finite element analysis tools, such as Creo ANSYS Simulation, Creo Simulation Advanced, those sorts of things. And the best part about this is we're still staying in Creo. So all of those loads and constraints that we laid out for CSL, we can just carry right over into ANSYS Simulation for that study. Now, overall, what we're able to do with Creo Simulation Live is take insight from our analysis tools and integrate that right into every step of the design process to truly use analysis-driven design and get us to the best quality design for our product. Now that you've gotten to see Creo Simulation Live in action, I do have a few more points I'd like to share that summarize what this tool can do for your companies. Before we do that, did any more questions come into the chat? I'm not seeing any.
Doesn't look like it. Let's go forward.
All right, sounds good. All right, so what does CSL do for you? Well, it enables you to do analysis early and often, and this is going to identify problems early in the design process before it's too late and it ends up being incredibly expensive and time-consuming to address and to fix. You're also reducing time to market through our concurrent design and analysis process, which allows us to rapidly explore design ideas and identify flaws and trends of our changes immediately on our design and in our design environment. And because of this, you're able to increase product quality and performance of your product and reduce the amount of spending on your product development costs and rework. So that's all for our demonstration today on Creo Simulation Live. Thank you everybody for coming and watching this demonstration. I hope it was educational for you and that you learned and that you're more interested in the tool. Let me take a look and see if there's any last questions here. And it doesn't look like there is.
Yep, I believe we don't have any questions here. I'll just hold another moment.
Sure.
And as just a reminder, if you enjoyed this presentation, we definitely encourage you to forward the on-demand recording with colleagues or share on social media. But with that, I did want to thank you, Zach, and everyone who attended. If you have any questions at any time, don't hesitate to visit TriStar.com to sign up for a free trial of Creo Simulation Live. You're also going to find additional webinar replays and more information. And like I said at the beginning, there is a handout section that kind of just is going to highlight a little bit of what Zach talked about today. And as always, don't hesitate to reach out to one of us if you have any questions later on. And thank you all and have a wonderful rest of your day and a lovely weekend.
Thanks everyone.